I want to start this clip quoting the popular slogan that Eric Evans used as the subtitle of his seminal book on domain-driven design, Tackling Complexity in the Heart of Software. Nowadays, every single architect, every single developer is struggling to find the most cost-effective way to tackle the complexity of the business in order to take projects home with mutual satisfaction. And here is another rather popular quote, divide et impera as it sounds in Latin, or divide and rule as it sounds in plain English. Historically, the maxim is attributed to Philip II of Macedon, but the Roman ruler Julius Caesar and the French Emperor Napoleon in their lives also developed very similar concepts. In domain-driven design, we find the same analogy. Breaking things in smaller and more manageable pieces is always key to win. During the strategic analysis, the business domain, if too complex to be handled as a single unit, is split in subdomains called bounded contexts. Each bounded context refers to a subset of the expected functions and becomes the grain of business logic to focus on for design and implementation purposes. A bounded context has its own wording, its own ubiquitous language. It has its own architecture and implementation and connects in some way to other contexts. Put another way, what would have been a single, comprehensive, and potentially overly complex software model for the entire domain becomes a collection of smaller and more focused models, one per bounded context. With the CQRS pattern on top of domain-driven design, you can gain even more. CQRS stands for Common Query Responsibility Segregation, and the pattern recommends you split any software model in two parts, command model and read model. The command model is essentially the business logic related to business actions that alter the state of the system. If you create classes here to implement business rules, you don't have to worry about making the same classes rich enough to serve also the needs of the presentation. If you reckon beneficial to use events in the persistence layer, for example, you can do that and choose an appropriate database without being constrained by business actions, other business actions that just need to read and report the current state of the system up to the user. There is the read model for that. And the read model is essentially data access logic, plain data access logic, only driven by the view of the data that the user expects. Hence, you don't typically need to have here rich classes with business logic, but most of the time, plain data transfer objects will pay the bill. Splitting the domain model means adopting the CQRS architecture. You therefore move from the canonical layered architecture of domain-driven design that you see on screen right now to a looser kind of architecture. In the canonical layered architecture, the same application and domain layers handle both commands and queries, and the command model and the read model are the same thing and live in the same space. With CQRS, things change quite a bit. The presentation layer still pushes commands and queries to the application layer, but now the application layer is split in two, and so it is the domain layer. Typically, the infrastructure layer remains shared and in common. However, persistence, the most relevant part of the infrastructure layer, can use distinct database technologies for commands and queries, commonly a NoSQL and a SQL technology. Note that there are many flavors of a CQRS architecture, and what I have depicted here is just one of many possible examples. The key part to understand the benefits of splitting a domain model in two parts and adopting subsequently the CQRS architecture starts from the picture you see on screen now, which is a subset of the previous screen. Users place commands and queries from the presentation, and two distinct and largely independent parts of the system handle them. The application layer gets parameters for commands as they are provided by users. The same application layer returns data after queries as users would love to see them. In other words, the application layer knows exactly the data that comes in and out of user screens. The domain and even the infrastructure layer, as a result, can be built just to make it easy and effective to process and return exactly the data that must go in and out of user screens. In summary, once users have approved the screens they like and the processes behind those screens, you only have to implement business rules and writing code. You know what it means? You cannot make it wrong. And more, you likely make it right the first time. This is the essence of UX-driven design, and the UXDD, the UX-driven design methodology, is just the topic we'll explore in the next module.